Welcome to Computer Networks and Protocol Lab. This is IPCC Lab with subject code PEC702. Here in this lab, the environment used in Computer Network and Programming Lab is Ubuntu. The operating system we are using here is Ubuntu, and we are installing this NS2 Network Simulator 2. There is one more environment where you can run NS2 using Windows operating system also. There you have to use Cygwin concept in order to use Linux environment. That is Windows System for Linux Environment, WSL. In our lab, we use this Ubuntu and NS2. Generally, a TCL script, that is nothing but tool command language, which is written in order to simulate the computer network scenarios. So this script is simulated using NS2 environment, which generates trace file, which contains all the information about the packets originating from source reaching the destination, whether it is received or dropped, like that. And along with the trace file, we are going to see NAM file, that is for animation, and for some plotting graph files also we are going to see. So in general, when a TCL script is executed in NS2, we are going to get NAM file and trace file. What are the steps that we have to follow? First step here is to write a TCL script. In order to write TCL script, you have to open terminal. In Ubuntu, you have to open terminal by right-clicking and selecting open terminal. And then you have to type the command gedit p1.tcl. Here, p1 stands the file name that is given with the extension of TCL. How to execute this? In order to check the errors and execute the program, in the same terminal, you have to type ns_p1.tcl. When the program is executed, we are going to get trace file and NAM file. So in order to analyze the trace file, again in terminal, you have to open a AWK file, gedit p1.awk file. Now we can use the trace file content in order to analyze with the help of AWK file. So what is the command in order to analyze? So again in terminal, you have to type this awk -f p1 awk, that is you have written here AWK file and link that AWK file with p1.trace, that is trace file. So the contents of trace file is analyzed by the AWK file here. In order to see the animation, you have to click the play button. To see the trace file content, you can type in terminal vip1.trace. What is p1 here? It is the name of the program. For example, second program is I can write gedit p2.tcl, ns_p2.tcl. If AWK file is written gedit p2.awk, if I want to link AWK with trace file awk minus f p2.awk p2.trace file. So like that you can give the simple naming for the files. First program in NS2 laboratory is this: to implement a point-to-point network with 4 nodes. With 4 nodes and a duplex link between them. You have to analyze the network performance by setting the queue size and bandwidth. So the following are the keywords here: point to point, that is P2P, and there are 4 nodes, and duplex links between this one. If there are n nodes, then I can have n minus 1 links here. So you have to analyze network performance by setting the queue size, and you have to vary the bandwidth. You can increase the bandwidth or decrease the bandwidth. You can assign the queue size higher or lower here. So the next step is to write the scenario. This is the procedure to write scenario for a given problem statement. How many nodes I have? 4 nodes I have. So you can name them as N0, N1, N2 and N3. After node declaration, you have to generate link between the nodes. So this will be the duplex link, this will be the second duplex link, and this will be the third duplex link. That means communication is happening both sides. So if there are 4 nodes, 3 links will be there. 3 links will be there. So after assigning links, the next important thing here is I want to assign agents here. Agents and application. So let us add UDP0 to N0 node, UDP1 to N1 node, and here for the destination, this is our destination, this is my source 1 and this is the second source node. So for all these destination, null V will be the receiving end here. So there is a logical connection established between this UDP and null. So in order to generate the traffic, we need application here. So CBR0 and CBR1 is attached to the agents here. CBR is nothing but constant bit rate. Constant bit rate. Now we have 4 nodes, 3 links with agent and application scenario here. Now the program. Let us analyze the program. So here the first statement is you have to create the object. You have to create a object by name NS. What is NS? NS is the object created for new simulator. So set NS new simulator. Observe here S is capital letter and rest of the letters are lowercase letter. The next one is, as usual, we mentioned that whenever TCL script is written, we must get NAM file for that animation file and trace file. So in order to put the content of this scenario in a file, trace file and NAM file, let us define the object for NAM file and trace file like this. Set NF. That is, NF is the object for the NAM file for writing, and here whatever the events that is happening in NAM file, that is NF object, is linked to the main object that is defined for the simulator. Similarly, trace file, This trace file is having the name p1.tr trace file. So whatever the events that is happening in trace file, it is to be reported to NS, that is the main object here. So this will be your first step and this will be your second step. So the next step will be you have to define the procedure. So it starts with procedure keyword PROC finish. This is nothing but the name of the procedure. Open and close flower brackets. Again open flower bracket. Declare the global variables here NS, NF and TF, whatever we have defined earlier. So clear all the variables. Next, you have to write close NF and close TF. That is nothing but trace file and NAM file here. So now you have to write here execute NAM. What is the name of the NAM file? We have written p1.nam and then exit 0 here. This is ampersand represent from the address here. So this is your third step. So all these three steps are common for all 5 or 6 program in part A. So the next step is here how to define the node. There are 4 nodes, 1, 2, 3 and 4. So N0 is nothing but the object that is defined for node. Okay, this NS is nothing but the object defined for the simulator. So this is the syntax set N0 within square bracket $NS node. So if there are 4 nodes, write N0, N1, N2, N3. The next 3 lines are nothing but you are going to name each node. $N0 is nothing but you have defined the first node, name it source. $N1 is nothing but second node, you name it source 2. And $N3 is nothing but your destination node here. So that is why here N0 source 1, N1 source 2, N2 is the intermediate node and N3 is the destination. So after this, we have to establish link between these nodes. So you have to consider this link creation. $NS, what is the type of link? Duplex link. So between which nodes? N0 and N2. That is N0 and N2. What is the bandwidth? 200 millisecond. Delay time? 10 millisecond. And type of the traffic? That is drop type. Similarly, you can write here also for these two link also. The next one is when the link is established, you have to define queue size for the link. What is the syntax? $NS, that is the object defined for the simulator. In order to define queue, you have to write queue limit. QUE hyphen limit, all lowercase. The queue limit is to be defined for the link N0 to N2. What is the value? 10. Similarly, you define for N1 to N2, N2 to N3. And after defining this limits, that is queue limits, you have to define the agent. So here is the scenario. There are 4 nodes. There are 3 links. This is N0, N1, N2 and N3. Now, to this I am going to attach agent UDP0. So in order to attach UDP0 agent to N0, you have to consider an object UDP0 for agent UDP. A is capital here, UDP is capital here. So to which node it is to be attached? So there is a keyword attach agent here. Attach agent $N0 $UDP0. That means UDP0 is to be attached to $N0 node. So all these events are reported to which object? That is NS. In a similar way, you write here the syntax for UDP1, which is to be connected to N1 node. Set UDP1 new agent UDP, and this UDP1 is to be connected to N1 node using attach agent keyword, and the event is to be reported to main object NS. The next very important thing here is we have to connect null here. So here null 3. So here again declare set null 3 object agent null. You please take care here. A is capital and N is capital, and rest of the letters here are lowercase. So define object for null which is to be connected to node 3. $NS attach agent $N3 null 3. Similarly you can connect one more here null 3. Since null 3 is already connected, so it is logically connected to UDP0, UDP1 like this. Now you have to connect logical connection between UDP0 and null 3. See, UDP0 and null 3, you have to use a keyword connect. Connect UDP1 and null 3, and then it is reported to NS, that is the main object. After setting up the agent, we have to set agent application. How to set the agent application? Again, you have to create a object that is CBR0. See here, it is application. What is the type? Traffic. It is generating traffic. What type of traffic? Traffic it is generating constant bit rate. And what is the packet size of that object? That is CBR0. It is 500. Here you please note down packet, after packet uppercase S, and then there is an underscore here. Then what is the interval of packet that is generated? For every 5 millisecond packet 500 bytes is generated. Interval underscore is here. And UDP0, to which node this is to be attached? This is to be attached to the UDP0. If this is N0, if this is UDP0, then I have to attach this one. So this is my CBR0. So in a similar way, copy these 4 lines and change CBR0 to CBR1 and retain everything, and you can change the interval and packet size here. So after this, you have to introduce the traffic here. At what time CBR0 start transmitting the packet, and at what time this CBR1 should start packet. So here I have written at point 1, that is at time instance point 1, CBR0 start, $CBR0 start. If you write CBR0, you will get error. So you have to write $CBR0 start. And then at point 2, time instant point 2, $CBR1 start. And at point 1, this is the initial time and this is the final time, finish. So start and finish are the keyword. To whom this is to be reported? NS, that is main object defined for the new simulator. So how to run the simulation? Run. To whom you are telling? The main object defined for the simulator. So this is the explanation about the program that is written for 4 nodes and 3 links. So now we'll analyze the output. Whenever this file is executed, on execution, you will able to see trace file and NAM file. Since I have some problem with generating the NAM file, I am not going to explain this. So we'll analyze the trace file here. So now what are the information that is there in trace file? So the trace file is having so many fields. First field is event, next is time, from node, to node, packet type, packet size, flags, and here is frame ID, source address, destination address, segment number, and packet ID. So these are generally considered as here 1, 2, 3, 4, 5 like this. So whenever we are going to write AWK file, you please check the trace file for this information. Here you are going to find R, plus, minus, and D. What is R represent? R represent receive, and plus represent it is at the queue. What is minus represent? It is DQ. What is D represent? Drop. So you start writing AWK file just like TCL file script gedit for example p1.awk file. Always you have to start AWK file with begin capital letter, and without space you have to write flower bracket, and you have to declare the variables which is integer type. What we are doing here, we are counting drop packet counting and received packet counting. Close this flower bracket. This is first section. Second section is you have to check only the first column. Start with open flower bracket. If $1 is equal to D, see, if $1 is equal to D, then you have to increase the drop count. Close. Again, if $1 is equal to received, increase the received count. Close. And this is the end of the middle part of the AWK file. The next part is end part. End without bracket, open the flower bracket. Write these two statements. You want to print the number of packet dropped is percentage %D. Percentage D is nothing but this is integer type. Therefore, you have written here percentage D specifier as in C. Now, what is the variable name? D count. What you have to do? You have to print here. Similarly, write the second statement and close it. So this is part 1 and this is part 2 of AWK file and this is part 3. Now, how to analyze this one? So you have to type in front of command prompt AWK -F. What is the AWK file you have written? P1 AWK. You are going to connect P1 trace file to AWK file. So on execution of this AWK file, you are able to see the output here. So you vary the link, for example, N0 to N1. You set some queue 10 or 20, like that. You set the bandwidth, for example, 100 megabytes, and then megabytes per bits per second, or 50 megabits per second, or 200 megabits per second. Note down the packet dropped and packet received. Similarly, N12 to N2, N22 to N3. You vary here the queue size 10 or 20, 10 or 20. So vary here the bandwidth and note down. So this is the explanation for the program. Now we'll execute using the Ubuntu environment. Now we are going to run the program using Ubuntu. I'm using Windows machine. So this is the Windows machine where you are going to see the virtual machine that is installed. So I have used this Oracle VirtualBox Manager, and we have installed the Ubuntu 24.04.4 LTS, which supports NS2 with NAM. So here you are able to see all the options. You can meet the lab instructor in order to install Ubuntu in your Windows system. So here I have partitioned the available hard disk space so that I have installed Ubuntu in E drive virtually, and in C drive Windows is installed. So in order to open a new terminal, go to Ubuntu. Anywhere you click on the desktop, open terminal. Now you are able to see the terminal is open, and you can type any command here. Since there are 30 to 60 students are there, they have to create their own folders. So go to files. So create your own folder like this. Right click, new folder. You can give your name. So I have already created a folder NKS. So right click and open in terminal. You will now see you are in that folder. So what is the command you have to type in order to open a TCL file? gedit p1.tcl. Click enter. Now you are able to see p1.tcl, which is open in subfolder NKS. Now you type the program and save here. So now I have typed the program in p1.tcl, and it is available in subfolder NKS. Now here you can see in terminal, since this file is open, you are not able to see the command line here. So in order to see the command line, press Ctrl C. That file will be closed and you are able to see the command line again. So now to run the file, you type here ns p1.tcl. Observe carefully here, in folder NKS only one file is there, that is p1.tcl. When I click ns p1.tcl, you are going to see NAM file and trace file will be available in that subfolder. Since we have issues with NAM file while installing Ubuntu, so I am not able to show the animation file here. Rest of the file we can show here, that is trace file. So once again Ctrl C. How to see the content of trace file? So vi p1.tr. You are able to see the contents of the trace file. which was explained as earlier. That is event, time, and then different elements that is explained in that trace file format. So the next very important thing here is how to analyze this. You are able to see the trace file. There are as many as number, the more than 10,000, 20,000 lines will be there here. Therefore, it is very difficult to count for us. That is why we are taking the help of the AWK file. So let us write AWK file. How to type AWK file? So close this our trace file, Control C. Now I have opened AWK file, P1 AWK file. Again in the same terminal you have to type gedit p1.awk. Now you can see as soon as AWK file is saved, you are able to see it is created in the folder. So now how to execute that? Control C. In command prompt, you have to type AWK -f. What is the name of AWK file? p1.awk. Which one you have to write here? That is the trace file p1.tr. Click enter. You are able to see some of the error here. That is AWK file line 6 error is there. Let us check it. Since the space was present in double equals, therefore we might have obtained that error. Once again close and run. Again you are going to see the error in line 17, the number of. So try to understand the error when you are going to get in the examination. See AWK, P1 AWK, that is the name of the file. In line 17, run away string constant, the number of. Again here also it is showing. So once again go to AWK and you are going to see line 17 here. Nothing is there. So it is already incomplete statement. Therefore, you can type this. So here I am going to type C count. C count. After this, I am going to write here one flower bracket. Now you are able to see the AWK file. Once again, execute this. You are able to see the output. Number of packet dropped is 153. Number of packets received. Actually, I have to write it here. Go to gedit. Number of packet here dropped. Number of packets received. Here it is received. Here we'll write R count. Save, close, and then run. You are able to see number of packets and dropped is 153, received is 337. So this is the analysis of the program. So in order to change the bandwidth, you have to go to the program, that is gedit p1.tcl. and you have to change here the bandwidth 200 MB, change it to 100, 150, change this to 200, change this to 2 MB, and you can change the Q limit also here, execute and obtain the output. So this is all about the explanation of the program, that is this is about the explanation for the program to implement a point-to-point network with 4 nodes and duplex link between them, and analysis the performance of the scenario by varying queue size and bandwidth. Follow the same procedure for the remaining 5 programs. First 10 to 13 lines are same, and remaining lines keep on changing depending on the scenario here. So I hope all of you will install Ubuntu in your laptop, or you will work in lab and complete part A programs, and part B programs will execute using C compiler in Ubuntu environment only. Thank you.